other type of presentations. So as we already know, the GM is current conduction, where we want to see the relation between if we change our voltage over here, and what happened in current in the collector. So that's why we sometimes we use GM, sometimes we use beta IB. So in case of common emitter that emitted in directly ground, so we prefer using the GMVBE. If we have emitter transistor, so we prefer you to choose beta IB, right? It because it's easy to make a computation. Later we can see the difference between two circuit, and we can do analysis, right? In the AC analysis, usually we using for amplifier. So what amplifier main factor that we want to looking for is gain. How much amplifier can gain up our output? So to see the gain formula, we need to divide our output divide by input. So last previous lecture we already derived this. So I think if you not understand, you can ask me. Um, if you know how to derive it, it's good because we can proceed to the next slide. All right, can we proceed? All right, we have an example here, some exercise. I think it's good to you to do the exercise here, and we can do discussions. So by giving this type of circuit, we have the source here. Just imagine our microphone over here, and we have V out, represent our speaker. So how do we find the small signal voltage gain? So to find this, we need to find AV V out equal to V out over Vs. Vs here, V out here. So before we proceed to this computational, first of all, we need to do the DC analysis first. And then later, we need to find AC analysis. It's because in AC analysis, we need to combine the AC, DC value. So first of all, we need to do the DC analysis. After that, we can do the AC analysis. Then from this AC analysis, we can find the gain. So let here examples. All right. All right. First of all, we need to do the DC analysis. So what the rule that we apply during the AC analysis first? So first, if you see the AC source, you need to short circuit. If you see the capacitor, you need to open circuit. But in this analysis, this circuit, we only have a AC source. We have no capacitor over here, so we neglect our capacitor. So we only short our source circuit. Then later we can do the AC DC analysis. So by short VS, we have straight there. So now we do the DC analysis. What the common thing that we need to find in DC analysis? First, IB, then we find IC, IE, we need to find VCE, Q, CQ. That's a common 4 element that we need to searching. So for the base, we need to do a loop. But here, fortunately, we have no RE, no resistance on emitter. So we have no RE. So it's easier to make looping to find the value of IB. So from the formula, it's easy in the analysis or mesh analysis or nodal analysis. We already know that source equal to voltage source equal to voltage load. So our source is VBB equal to IB. IBRB, we have VBE here plus VBB. So to get the IB, we need to bring VBB minus VBE, and then RB bring to right side, then divide the voltage, and then 5 minus 0.7 divided by 50, we got IB is 10 milliampere. All right, same. How to get VBB minus VBE RB from these derivations. Understand? Clear or not? Say okay on the chat box if you have, if you understand. If not, just say no on the chat box. Okay or not? Okay. All right. Thank you, Akmal. Thank you, Hadi, Mekin. Okay. Thank you. All right. Jun. Okay. Now we already know the VB. So we need to find IC, VCE. All right. If we do a looping, we already know that the source equals to voltage load, voltage source voltage equal to voltage load. So our source is VC equal to IC RE, IC over here. And then we have VCE, but we have no RE. So we know a value IE or RE here. So just leaving over here, VC equal to IC RC plus VCE. So as we already know that IC equal to beta IB, because of beta already given on the equations, so beta equal to 100, we can find the IC. Oh, IC. So IC equal to beta IB, so we already know the IB, so we get 100 times 10 milliamp, so we got 1 microamp, we got 1 milliamp for the IC. All right, to search the VCE by replacing the VC over here, or by replacing ICRC over here, so we got VCE equal to VC minus ICRC. So we already know the IC is 1 milliamp times the 6K. We got value here, and 12 minus this, we got 6. 12 minus 6 equal to 6. So we got VCEQ, VC equation equal to 6 volt. Don't forget the units. Oh, don't forget the unit. If you didn't put the unit on the examination questions, the marks will be deducted. So now we got all the value IB, ICQ. So we not compute IE because no IE over here because has no because no resistance. If you want to still want to compute, it's okay by using IE equal to alpha IC if you want. So beta equal to alpha equal to beta, beta plus 1. You can still compute the IE, but inside this analysis, we not require the IE. So we got IB, IC, and VCE. So if you realize all the notation must be in capital letter. All right. So after that, after we run the this analysis, now we can looking for AC analysis. So as we already learned that if we want to proceed to AC analysis, we need to um, open circuit if have inductor. We need to short circuit if have capacitor. We need to ground it, ground for DC source, and we need to open circuit if we have no voltage source. If we have a DC current source. Okay, in this and in this circuit, we only have the DC voltage source, so we need to ground it. So as a result, we got here. So RC we connect with the ground, and from the source VB we connect to ground. So we got here. So to analyze the small signal, so we need to convert our VGT into the hybrid form. So hybrid form like pi here, pi connection here. We have R pi, we have GMVT. Sometimes we use GMVT, sometimes we use GMVBE. There's a same notation over here. So so to to find the ultimate, our finding is to find the gain. Our gain is ultimate calculation that we want to find. To find the gain, we need to divide V out our VS. So the V out formula is GMVTRC. How we know this formula? V out located at the right side. So this voltage V out equal to voltage around here. So what is around here? GMVT is convey the current. So current times the resistance RC, we got the voltage. That's why V out equal to GMVT times RC. So current times resistance over here, we got the voltage. This voltage represent V out. Okay. First, we got the formula for V out. Alright. First. Second, we need to know what our source voltage. So our Vs came from here, from here. So as we know, to find the Vt, over here or VBE, uh, we need to do voltage divider. So voltage divider, voltage current drop around the R pi. The voltage drop the R pi is the Vt. So because um, we have RB, so we need to do the voltage divider. So voltage drop the R pi is Vt equal to R pi over R pi plus RB times Vs. So from this formula, we can derive to find the Vs. So Vs stay over here, and then we need to bring the resistance R pi plus RB over there, and R pi bring down. So we got here R pi plus RB over R pi times Vt. This our formula for get the Vs. So if we combine Formula 1 and Formula 2, we can find the formula for gain. So we put top of uh, equations, and for Vs we put the below the equations. So by rearrange here, we got two same notation, Vt, GMVT RC for the V out, and we have R pi plus RB over R pi times Vt for the Vs. So if then we can see they have a same notation Vt, so we can remove it by divide these two equations. So by rearrange, we got GMRC times we bring, because the divide and divide, so we can bring R pi up the equation. So R pi over R pi plus RB times GMRC, we got formula for AB. But now, formula we already know, but how to know the value GM here and R pi here? RC we already know, but the value R pi and GM we still don't know. So to find the value R pi here, we already know IB. So we need to know VT. What is VT? VT times divided by IB, we can get the value of R pi. So in this condition, if the question is a question that give you value of VT, you need bear in mind and remember VT usually equal to uh, 26 millivolts when the our BJT device at room temperature 20 Celsius. Bear in mind, sometimes question not giving you VT value, or either appendix not given you the value of VT. You need to remember that VT 26 millivolt, or certain books they're using 25 millivolt. So if you know the value of VT, and then you can find the value R pi, and then um, to find the value GM equal to IC over VT. So IC we already know, and then VT we know is 25 millivolts. So R pi equal to VT over IB. So VT is 25 millivolts over IB is 10 microampere. Oh, R pi equal to beta VT. Sorry, they have beta VT. Beta VT over IB beta VT over ICQ. So 100 is beta, 0.026 is our VT, and divided by ICQ, we got ICQ equal to 1 milli. So 100 times 0.06 over 1 milli, we got 2.6k ohm for the R pi. To seek or to find the value of GM, we need use IC over VT. So why it came this formula? GM VT is a current of IC, so equal to IC. To find the GM, so IC over VT. So VT already know, IC we already calculate 1 milliamp. So 1 milliamp divided by 20 milli 26 millivolt, we can get um, 1 over 0.026, we got 38.5 milli ampere per volt. That's a formula. That's a unit for transducer. Transducer, betul? Alright. After you got the value of GM and R pi, you can plug in all the value GM here and R pi over here, and then we can find the value of our gains. Here we got the gain our is minus 11.4. Means that our signal input, the output of our signal is inverse direction of our input, but it gain is 11 times. Alright, if our Vs in this phase, so our V out will be inverse like this. So the size multiplication is 11.4 times bigger than our V in. Alright, any question? Faham ke tak faham? Boleh tanya. Kelah saya laju sangat?
Sure.
Ya, yeah.
Saya nak tanya dia
Boleh
IC
Aslam.
dengan ICQ tu dia sama.
Sama. Kalau kita kira IC biasa tu, kira hot yang kita kira tu, hot tu lah ICQ. Maksud dia hot paling molek dah hot yang kita kira. Q tu kan the quotient yang kita dalam apa? Load ni apa tu load line kita. Hak Q tu kat letak tengah-tengah kan. Dia tak kena saturation, dia tak kena cut off. Maksud hak yang kita kira tu hak cantik dah. Kalau kita kira tu kita boleh nama dia ICQ atau VCEQ. Hak tu maksud dia hak paling cantik hak kita kira.
Sama lah.
Sama. Betul.
Okey. Okay.
Beres. Alright. Faham ke? Boleh? Yang lain? Okay.
So, yang
ya Syayuti.
Yang V tu memang fix dah.
Yang VT?
Dia punya nilai.
Ya, VT tu pakai 0.026. Kalau question tak bagilah. Kalau question tak bagi kita assume 0.026 ataupun kita pakai 0.025. Kebanyakan buku pakai 0.025. Saya tak tahu kenapa lecture note ni pakai 0.026. Tapi kalau dia tak bagi, hak ni lah value kita pakai. Tulislah dengan okay, fix, betul fix. Betul. Nanti you kena tulislah dalam you punya jawapan tu at room temperature 20 value VT equal to 26 millivolt. Macam tu lah. Sebelum kita start calculation. So nak beritahu kat pensyarah, kita pakai this condition. Okay, kira fix lah tu. So kalau ada VT, kita selesai masalah. Kita boleh cari AV. Untuk case ini hanya terpakai formula ni. Susah juga nak ingat sebenarnya formula ni. Sebab formula ni terpakai untuk emitter yang kita tak ada RE yang kita, sebab emitter ni kita connect direct ke ground. Kalau kita pakai yang ada contoh kita letak resistor dekat emitter, formula ni dia akan lari sikit. So, saya suggestkan anda faham macam mana nak derive berbanding you guys hafal. Takut nanti tersalah bubuh formula. Oh, kalau nak hafal ni, hak ni, nanti saya boleh bagi. Okay. Alright. Saya boleh proceed?
So nanti calculation tu saya bagi ke?
Yang mana? Yang ni, nak ni? Contoh
Ah,
ni? Boleh-boleh nanti saya bagi dalam, saya bagi dalam Google Classroom lah.
okay baik sir.
Tapi tak apa kau tulisan tak cantik ni. Saya conteng-conteng. Kata orang pelik panggil contiang. Tulisan saya tak cantik.
Apa sir? Tak apa sir.
Oh, okey. Pujuklah tu.
Sir,
Okey. Ya.
sir.
Ya, Islam.
Kalau dekat itu ada resistor kena kira lain ya.
Hak lepas ni kita tengok slide-nya ada resistor. Hak pelik sikit
Okey.
lah kita tengok kiraan dia.
Okey
Tapi
sir.
nak bagi faham, kita tengok hak mudah dulu. Kita tahu
Ya.
nak dirah hak mudah, kita boleh buat yang susah.
Okey sir, okey.
Alright. Okay, before we start next slide, so we have some break. I provide you a quizzes, so you guys can join my quizzes. If you got the highest top 3 marks, I will provide you presents. So